$154 cost me this one Lambda function. And I could reduce it after just 2 months to $4. And in this video, I want to show you the 5 tips on how I would approach Lambda cost optimization and Lambda cost savings, because I think many of you out there pay way too much for your Lambda costs, because Lambda is supposed to be cheap. Lambda is supposed to be a serverless platform where you only pay for what you use. And I think many people and many developers set up their Lambdas once and never take care of it again. And I have a 5-step approach of how I go over these things, and I'm going to show you exactly how I'm doing that. Hey everybody, for those new here, I'm Sandro and I've been building AWS full stack solutions for the past 6 years. I've built solutions which millions of users used out there, and I think I made every costly mistake out there. I'm building right now a Shopify app called FraudFalcon together with a friend, and this will be the showcase video today because we faced the exact same issue. In this video, I want to show you the 5 practical ways of how I would go ahead and start saving Lambda costs. And I would do them in exactly this order. The first step we are doing is we actually need to understand our Lambda costs. And this part is really crucial. So I have shown you my Cost Explorer here. So Cost Explorer will be your best friend if you want to optimize costs, which sounds obvious, right? And we can see that the service Lambda is by far the most expensive one here in February, because we paid $155 just for Lambda. And we want to improve on that. If we skip over to April, we can see that we only pay $4. And even in those 2 months, we scaled the Shopify app a lot. We got many merchants, we get many more orders because it was just launched properly in January. Before you start optimizing anything, you need to make sure that you understand your costs and understand your costs where they're coming from. Because I like to always use the Pareto principle here as well. Just focus on the 20% of services which are emitting 80% of your costs. And if I look at this graph, I would only focus on Lambda and probably only on a few Lambda functions. As a second step, what I would do now, I would look at daily costs. But for that, we need to set up one setting. If you can't select the granularity daily here, we need to set it up. But if we look at the granularity here, this is how we can see also which costs are emitting on which day, which can be much clearer to get a better picture here. So for setting this up, we need to actually go into our settings. But since I'm running in an AWS organization here, I need to go to my management account in the Cost Explorer setting, because this needs to be set up from the management account. So I just switch the tab here and I go into the management account. This is the Cost Explorer of my management account, so over the whole AWS organization. And then we go down into Cost Management Preferences, into Cost Explorer, and here we can tick Daily Granularity. And you can choose the services. I simply chose all services. Let's activate that, and then it takes some time, and then you can see daily data. Here we are back in our production account, in our member account, and we can see our data here, our daily data. The next setting I would set up are cost allocation tags. What we now want to do is we want to see which Lambda function is actually the most expensive one. Unfortunately, back in January, I didn't have this setup ready as well. So I needed to change the dates a bit. I'm between June and September now. And here I don't group by service anymore, but I group by tag and by the tag function name. And here I can see it's still one Lambda function. You see it is much less. So I already optimized the Lambda function then, but you can see that it's much less, and you can see it's only one Lambda function, the orders create events queue subscriber. And we can see the same pattern here over and over again. But to actually achieve that, you need to do 2 things. First of all, you need to set up this tag function name. This hardly depends on your infrastructure's code framework. With CDK, for example, you can use CDK aspects to tag all of your resources. In SST and Pulumi, I use a transform function, which goes through each Lambda function and adds the tag function name. If we look at some Lambda functions, so we can simply look at the most expensive one and look at the tag, then we can see that we have the tag function name, which is exactly the one we have just seen. This is the one thing we need. So we need a tag to group by the cost allocation tag, but we also need to go into Cost Explorer and set up this cost allocation tag. And you can do this here from the left side in cost organization. Again, I'm in the paying account, so I'm in the management account. You go into cost allocation tags and you can select your cost allocation tags. Here, for example, I said function name. I've activated this one, and that's it. This is how you can get your cost allocation tags. As you can see, if your Lambda function didn't have, for example, this tag back then, it won't help you. So this is why I don't have any historical data in January, but this is the crucial setup that you actually understand your costs. And now we can come to the fun part, to actually optimizing our Lambda functions. Now we're going into step 2, reducing memory. But before we optimize any memory, we need to understand how Lambda is actually built, because Lambda is built by gigabyte seconds. And this brings us down to 2 dimensions, 1 to the gigabyte, which is the actual memory, and 2 to the seconds, which is the time the Lambda function runs. So these are always the 2 dimensions you can improve. And your memory can be analyzed by using logs. And there's one specific log that you always need to look out for. I'm in CloudWatch. I go into the log group of my most expensive Lambda function, order created events. I just open some log stream, and we can see if a Lambda function finishes, we have this end log with the request ID, but we also have the report log. And if you look into the report log, we can see the duration the Lambda run, the build duration, and the memory size and max memory used. So you can already see the memory size is the memory size we've attached to this Lambda function. And the max memory used is how much was actually used. And now we can go into logs insights and analyze this log line over all Lambda executions, because this log line is always printed out in the CloudWatch. For that, I go into logs insights. And what you could do, first of all, we select our log group. Second, what you could do is you could go into save and sample queries. And there is even a sample query for Lambda, find the most expensive requests, or determine the amount of over-provisioned memory. And this is where what we actually are interested in. We want to see the amount of over-provisioned memory. And here we can already see, if I'm just doing this for the last hour, we can see the smallest memory requests were just 256. The average were 1.3 gigabyte and the max was 2.1 gigabyte. And in that case, it would be over-provisioned by about 800 megabytes. I typically use another query just to see it a bit differently, but feel free to use the query you like. We can also change here a few things just to make it a bit more understandable. And here we can see that, for example, just 50% of the memory assigned is used. But there's one important part that you need to understand. So don't go in your Lambda settings now blindly and just reduce the memory. Because what happens together with the memory is the attached CPUs. Because the only infrastructure setting you have in Lambda is that you can attach memory. And the higher the memory is, the more CPUs your Lambda function gets. Unfortunately, the interaction between memory and CPU is not 100% clear, so I can't find much information about that. But there used to be a really cool blog post by FraudFalcon which shows you the provisioned memory and the allocated cores. And this shows you if I add more memory to my Lambda function, I will also have more cores available. If you use Node.js, for example, you really need to understand if this is of any benefit to you, because you need to parallelize things and you need to understand it. But it's just important to understand that you can't simply blindly turn it off. And what I would recommend doing is using the tool called Lambda Power Tuning from Alex. He built a tool where you have a step function and you can execute your Lambda function multiple times with different workloads and especially with different settings. The step function is then also updating your Lambda settings, and then you can see the sweet spot between execution time and execution cost. Because it won't help you if you reduce your memory by a lot, but your execution time skyrockets. Then it can happen that you have less memory attached, but actually pay more for this Lambda function because it simply runs longer. And this is what the tool Lambda Power Tuning will show you. Of course, if you have a bit more Let's say you have an API Lambda function which has different workloads and which also depends on the user context. It can be a bit hard to mock, but I think this is definitely a starting point if you want to analyze your Lambda functions. Use Lambda power tuning. This was step 2 now. Step 1 was looking at your data. Step 2 was reducing memory. In step 3, we now look at the timeout and how long your Lambda function should actually run. For that, we go back to logs insights. We remove our log here. And what we're doing here is we analyze the average, maximum, and P99 duration of your Lambda function. Because again, we have two-dimensional Lambda builds on, gigabyte and seconds. We took care of gigabyte by reducing the memory, but now we go ahead and take care of the seconds of how long your Lambda function actually runs. So what I did now, I copied out the new logs insights query. You can get it from the blog post as well. And we're doing a few things here. And the main part is I'm interested in, I have a bit of 1 day and I can see how many invocations we had and the different durations we had. And here, for example, we can see the max duration here was 900 seconds. 900 seconds is actually 15 minutes and the Lambda maximum timeout is 15 minutes. So this is always a sign to look out for, because you need to understand if your max duration is 900 seconds, there are few invocations which run forever. But if you look at the P99, it's just 16 seconds. So there's a huge difference between those two. And it could also mean that maybe just some invocations are running into a timeout because you are in distributed systems. So maybe you talk to another API and some invocations run into a timeout and just cost you a lot of money. This is why I would always look out for the P99 duration and set the timeout on the P99 duration with some buffer, but also analyze these single invocations which cost you so much money. Because of course there can be a customer which just has so much data, so it takes much longer. But what the typical case in my opinion is the execution, the invocation hangs for 15 minutes, then it fails anyway, it will be retried, and in a retry it's done in a second. And if this is the case, just keep your timeouts very low, because then you face your issues much earlier and you simply save costs because your Lambda function is running less. But be aware, this is only possible if you have proper monitoring, if you have CloudWatch alerts, and if you understand what is going on in your invocations. This was step 3 about reducing timeouts. Step 4 is about the architecture your Lambda function runs on. By default, I would always go to ARM architecture, because ARM architecture is 20% cheaper compared to x86. If you look on the Lambda pricing page, we scroll down a bit and we can simply see here our gigabyte seconds. What I'm talking about is how it's built at the moment. And then we have an x86 price, and then we have an ARM price. And you can see we are only talking about duration, not requests here, that the duration prices are way lower just simply based on the architecture we use. And the architecture change can be a very simple one, because if you don't use many libraries, or if you just use SDKs from AWS and maybe do some data transformations, this could be really one checkbox and you save 20% of the costs. But it's important that you test out your workloads. I also had clients where I was very keen on changing that, but I had no chance of changing that because they used libraries, and some libraries of course depend on the architecture, and then I couldn't do it. One of those libraries is, for example, a really cool validation library in Python called Pydantic, and they had an older version, so I think it was in version 1, where you couldn't use ARM for Pydantic. But I want you to understand that there is no free lunch. So if you're changing the architecture, you're changing the architecture. It can be a super simple change, but if you have a very complex Lambda, especially with many dependencies, please check it out. Please run your tests again. Please run your workloads again, and only then change it and put it on production. Now we talked about the 4 steps on how we can reduce the Lambda function costs, but I haven't actually told you of how I save the costs for my Lambda function. So how I went from $155 to just $4. And yes, we did these steps as well, but they didn't have the biggest impact, because how our Shopify app works is the following. what we're doing is we get a Shopify order from some merchant. So somebody orders something and we get a copy of the order into EventBridge. And EventBridge forwards this to Lambda, and Lambda then actually looks in the order and says, is this fraud or not, and reports it back to Shopify. But since we scaled up this app in January and February and got lots of orders in, you need to imagine that for each order we get one event, and for each event we get one Lambda function. And this can be quite expensive. If you have shops that have hundreds of thousands of orders each month, Lambda needs to scale a lot, and the cool thing is Lambda is scaling, so you won't have any downtime, but it gets very expensive. And the main part we have changed is we've introduced batching, and this is actually what I would always do as step 5, is to look at your Lambda functions or look at your overall architecture and think where you can use some batching. Because what we do now is we still have the same setup of one Shopify order comes into EventBridge, so one Shopify order is one event. But now instead of putting it into Lambda, we put it in SQS. And SQS is the message queue service, so we now have many messages in SQS, and we have some batching windows, so that means we wait for half a minute, for example, before we give all of these orders into the Lambda function. And the Lambda function then gets a bigger payload size, so it gets much more messages, but it still can handle that. And then we can work on that in parallel and check out all of these orders and see if they're fraudulent or not. And this reduced our Lambda function costs by a lot. I wouldn't start with that, to be honest. So it was still good that we started out like that, because you still want to bring customer benefit, you want to be fast, you want to launch, but have it in the back of your mind that batching is a huge benefit and can save you so much costs. This is now just for Lambda, but it's the same thing for DynamoDB, for S3 and many other services. And I think step 5 comes down to using Lambda less, because what we're doing here is the actual magic here is not that we batch, but the magic is that Lambda runs less time than before. We have less gigabyte seconds than before because it is running much faster per order, because we have a huge amount of orders in one Lambda execution. And this can also come down if you have a Lambda function which is, for example, can be replaced through direct integrations. If you're using AppSync and you use a Lambda function for each resolver, you could also save costs by doing direct integrations with DynamoDB, for example. Same thing with API Gateway and Lambda. All of that comes down for me to using your Lambda functions less time, because if you batch it, you will use it less. If you cache, for example, if you cache at database level and your Lambda function doesn't even need to be called, it is used less. And if you use direct integrations, it's the same thing. We don't need to use our Lambda as often as without. So these are the 5 steps. I would recommend that you do them. First of all, understand your costs, set up your cost allocation tags, set up granular costs. Then go ahead and look at your memory, reduce your memory if necessary. Then go ahead and reduce your timeouts, that you actually know what your outliers are, and also just don't pay for some timeouts, for example. Switch to ARM, and in the end, use your Lambda less by batching, caching, and direct invocations. I put together an infographic for Lambda, which covers everything from how to set up a Lambda function, how to optimize the memory, what the different architectures are, what cold starts are, and so on and so forth. You can get it for free. I've put the link down below. If this helped you actually save some money on Lambda, please let me know. I'd love to hear the stories, and I hope I could help you. See you soon. Bye bye.